So in this collab, I'm going to be covering probability distributions, and I'm going to start off with the binomial distribution. So let me share my screen. All right. So what are probability distributions? Well, probability distributions are handy ways of determining probabilities when a random variable behaves in a certain way. Depending on how it behaves will dictate what probability distribution you use. So let's look at an example to kind of put things in perspective. So if you read this example, which says once a week, a merchandiser replenishes the stocks of a particular product brand in 6 stores for which she is responsible. Experience has shown that there is a 1 in 5 chance that a given store will run out of stock before the merchandiser's weekly visit. Okay, so what this actually means is you've got 6 stores, so I'm just gonna, there's 1, 2, 3, 4, 5. Okay, there's only 6 stores. And there's, if you read the passage and then look at the first question, it says what is probability distribution? What probability distribution is appropriate in this problem and why? Okay, so since you've got 6 stores, right, you can think of them as experiments. So you have a fixed number of experiments. All right, there's only 6 stores, so your number of experiments is 6. So your n is 6. All right, now I'll get to what these symbols mean in a second, how we can use them. So we've got 6 trials or 6 experiments, and basically in each experiment there's only 2 outcomes. What are those 2 outcomes? Well, if you read the passage, it says that each store either runs out of stock or not. All right, so that's two possible outcomes. It either runs out of stock or not. And the thing is, there's a probability given to one of those events. Now, if you have the probability of it running out of stock, you can determine what's the probability of it having stock, because they complement probabilities. All right, so it says, if you read the passage, it says there's a 1 in 5 chance that a given store will run out of stock. So 1 in 5 is actually a probability, so I'll represent that by P, 1 over 5, and you could write it as a decimal if you want, 0.2. Okay, so we have a fixed number of experiments. There's only 2 possible outcomes, right? And the passage doesn't say this, but we can assume that each store is independent of each other. So with independent trials, or should I say independent experiments, there's a fixed number of them, which is 6, and there's only 2 possible outcomes. That's an indication of a binomial distribution. Okay, so remember that. Fixed number of trials, right? You can assume that they're independent of each other, and there's only 2 possible outcomes in each of those trials. So that makes it a binomial distribution if those 3 conditions are met. So the answer for A, it's a binomial distribution. Right, so let's go on to the next question. It says, what is the probability that on a given weekly round, the merchandiser will find exactly 1 store out of stock? So let's look at what they're asking for, right? They want to know the probability of one of the stores running out of stock. So the thing is, you can have at most only 6 stores running out of stock. But they want to know what's the probability of just one of those stores. So what you would need to let be a random variable is what you're interested in. So we would say let x, right? That's going to be the number, I'm going to represent it by a hash, number of stores. Okay, so stores out of stock or running out of stock. Okay, and now if we look at the question B, they want you to determine what's the probability, so we represent that by P, of on any given week the merchandiser will find exactly 1 store out of stock. So that's, in other words, saying x equals 1, right? Because we just said it's the number of stores out of stock, and if x is equal to 1, that means 1 store is out of stock. So we need to find this probability. Now this is where the probability distribution comes in, because we know if it follows a binomial distribution, we can use this equation that's given here. And this formula is given to you in your formula sheet. You just need to identify when you can use them. Okay, give me a second. I think my mouse, it's back. So now that we can use this formula, it's just a matter of substituting the values into the equation. So you want to know the probability x equals 1. So you just need to substitute into this ncx. So the formula is actually ncx. Sometimes your formula sheet might have r instead of x, but it's the same thing. All right. And times p to the power x, right, times 1 minus p. Sometimes your formula sheet might have, instead of 1 minus p, it might have q, but just know that it's the same thing as 1 minus p. And that to the exponent of n minus x. So we have our n, which is 6, we have our p, which is 0.2, and we have our x, which is 1. All you got to do is substitute it into this equation, right? So ncx, n is 6, right? This here is combination, right? You would use this on your calculator. You'd enter it in your calculator, so it'll be 6 c, your x is 1, your p 0.2, 0.2. We raise that to the power 1 because that's what our x is, it's 1. And then 1 minus p, which is 1 minus 0.2, all to the power n, which is 6, minus x, which is 1. And if you enter that to your calculator, you will get a value of 0.393, 0.393. Or you can write as a percent, which is 39.3%. Now you would have to provide an interpretation. So remember what we were answering. We were answering B. What is the probability that on any given weekly round, the merchandiser will find exactly 1 store of stock? So the question kind of gives you an idea of how you should provide a statement. So you can say the probability, I'll make this a bit larger in a second, of 1 store having no stock is 39.3%. Always provide a statement. Let me make this a bit larger. Oh, sorry. That should be fine. That's your statement. And that's how you'd answer the question. Do the working, substitute the values into the equation, get a probability, and then provide a statement to conclude. All right, so that's how you do B. Let's do C. All right, so C, I'm just going to erase this. All right. C is, what is the probability that at most 2 stores will be out of stock? When you say at most, that means you include, right? So that means you have a less than equal to. At most means less than equal to, and it says 2 stores. So x at most 2. So x being no greater than 2. And you want to find that probability. Now this is not an equal to sign. This is not an equal to sign. It's an inequality. So it means 0 satisfies it, 1 satisfies it, 2 does as well, but nothing over 2. So you would need to find the probability of x equals to 0, right, plus probability of x equals to 1. Remember, x can always equal to 0 because you can have no stores being out of stock. X equals to 1, and then x equals to 2. And make sure you stop there. You must understand how inequalities work. Less than equal to 2 means at most 2, so 2 will be the highest, then you count down 1 and 0. All right. Now, just like how I did the previous example, each one of these equations, you'd have to substitute the value of x into it. Now, we did this one earlier, right? This was 39, I believe 39.3%. Okay. So you need to work out these two, right? And yeah, so you need to work out these two just like how we did in the previous example, right? So you need to provide a 0 into this formula here, but your n does not change and your p does not change. And you do the same thing for x equals to 2. You put 2 in for x here, and then your n and your p doesn't change. And if you do all of that and then you add it up, your final answer would be 0.901, or in other words, 90.1%. All right, you should try this example out and aim to get this answer here. So you've already got one of them worked out in the previous question. You just need to work out this one and this one. These two other probabilities, add them up, and you should get this answer of 90.1%. And remember to interpret. Okay, always provide an interpretation. I won't do that for this example. I'll leave it to you to do as an exercise. All right. And I'll do, we've done C. Let's look at D. I think you're getting the hang of it now. All right. D. What is the probability that no stores will be out of stock? That is simply saying, what is the probability? Now, remember, X is the number of stores out of stock, and we're saying, what's the probability that no stores? That means X equals to 0. And all you're going to do is substitute 0 into the formula, and your n does not change, as I said before, and neither does your p. And if you put all those values in, you should get 0.262 or 26.2%. 26.2%. All right. So we do it exactly like how we did it for question B. Right? For B, we substitute 1 for x, but for the question D, we're going to substitute 0 for x. All right. 26.2%. Remember, provide an interpretation or provide a statement to conclude your answer. All right. And then the last one is E. And E it's actually quite simple, right? What is the mean number of stores? What is the mean number of stores out of stock each week? Now, for binomial distribution, the mean or the average are represented by mu, right? It's your n times p, and that's how you find the average, right? So n is 6, so 6 times, and your p is 0.2, and if you multiply that, the answer is 1.2. That's what your average is. So on average, there's about 1.2 stores out of stock each week. You can leave the decimal. I know 1.2 stores may not make sense, but if you want to round it, you would obviously have to show the working of how you got the decimal, and you can, as a statement, you can say almost one store on average is out of stock each week. All right, I hope that gives you a good understanding of the binomial distribution. I encourage you to work through these questions, and this should give you a really good understanding of binomial distributions. All right, so I'm not going to cover the Poisson distribution, which is the other discrete distribution. What I am going to cover instead is the normal distribution, which is a continuous distribution. So let me give you an example. All right, make sure I am recording again. Audio is fine. Okay, great. Alright, so the normal distribution, now this random variable is different. Okay, it's continuous. What do we mean by continuous? As you know from your earlier learning units, a continuous random variable can take on decimal values, right? It's not just a counting number. So let's look at this question here. A recent survey by a local municipality established that daily water usage by its households is normally distributed with a mean of 220 liters and a standard deviation of 45 liters. Now you can see this can take a decimal value because you can have 30.45 liters, right? You can have decimals. Now it says it's normally distributed with a mean of 220 liters. So what it means is when something is normally distributed, let me draw a chart to kind of give you an idea. It means whatever that variable is, we can represent it on the x-axis. This horizontal axis, and in our case we'll call it x. And what this x measures is if you look at the question, it's the daily water usage by households. So x is your daily water usage by households. I'm going to put it here. Daily. Let me type this instead. Okay, so x is daily water usage. Right, that's what our x represents. Now, I don't know where this line is. Why is this line here? Oh, oh dear. It disappeared. Fantastic. Right. So, the question says that x is normally distributed with a mean of 220. So what that means is, let's say our 220 is here. Okay, that means this follows a bell-shaped curve. Now, just forgive my drawing. I'm not really great at sketching. I'll do my best. It's a bell shape. Okay, and the peak is centered at 220, and this is symmetric, right? So it means what you have on the right hand side of this dashed line is identical to what you have on the left side. All right, so this has a good property in that we have a table that can actually give us these probabilities. All right, so what the first question says is use the standard normal Z tables to answer the following question. So the first question is, what percentage of households is likely to use more than 300 liters per day? Now, what they're saying is, what's the probability? Now, we've mentioned that X is our daily water usage. So they're asking, what is the probability of X being more than, right? More than 300. Okay. Now, for a continuous random variable, it doesn't matter if you actually have greater than or equal to. If you had greater than, or if you use this, it doesn't really make much of a difference. But that's only for continuous random variables. So in our case, we could get away with using both, right? Just a point of interest. All right, so we want to know what this probability is. Now the thing is, in our textbook and exam, you'll be given a formula sheet and you'll be given tables. Now we only have a table when a variable follows a normal distribution and the mean is not 220 when the mean is 0. So we have an equivalent bell-shaped curve. It's identically shaped, right? But the catch is that the horizontal axis is Z and the center is 0. Now, if a variable did follow this normal distribution, we would be able to determine this probability because we could use the table that's provided to us. So what we do is we do a little trick to convert the x into a z. And how we do that is by using this formula here. We say z equals to x minus its average divided by its standard deviation. Now we're given its standard deviation. You read the question. Sigma is 45. And mu is 220. Right, so instead of working with x, I'm going to change this. We're going to make it probability of z. But remember, to make an x into a z, we need to take whatever the value is, which is in our case 300. We subtract its mean. If you look at the formula, it's x minus mu. So x minus the mu is 220, and then we divide by standard deviation, which is sigma, which is 45. And this will give us the same probability. Now, if we simplify what's on the right hand side of this inequality, it becomes the probability of z greater than, and I believe that value should be 1.78. We'll round it to 2 decimal places. All right. Now, this probability, this notation, what it's saying is, look, now we have the z curve, right? And we're looking at what is the probability when z is greater than 1.78. So this is the z-axis. Say, if it's centered at 0, then all positive numbers will be on the right of it. So 1.78 has to be on the right of it. If it was negative, then it would be on this side, but it's not. 1.78, it's a positive number. It's here. And we're saying if 1.78 is here, we want to know what's the probability of z being greater than it. In other words, the probability can be found when you determine the area under the curve. Okay, you need to find this area under the curve. And we want to know what's the area on the right of z being 1.78. Now the thing is, in your textbook, and I'm going to use a different color here. Second, your textbook gives you this area instead. It gives you any area from 0 to a z value. If you tell it what the z value is, it will give you the area from 0 to that z value. All right. Now the thing is, we can use this to get the black area. All right. What you should know, and what you must know actually, is the entire area under this curve. For this entire curve, the entire area is 1. So if we split it down the center by 0, because 0 is where the average is, and remember it's symmetric, so you have an identical shape on the left as you are to the right, the area on the left of the dashed line is 0.5. So the area on the right must be also 0.5, because the total area is 1. So what I'm saying is, the entire, let's use a different color, the entire area from this 0 to all the way to the end, right? All the way to the end. If you take this entire area, that will be 0.5. So if I only want the black area, I need to take 0.5 and remove this green area. And the green area we can find from our table, okay, in a normal distribution table. So what you do is you go to your normal table in the back of your book, and you'll see that there's a z value here, right? Your z values go down vertically and horizontally. So let me open the textbook. Give me a second. Okay, I'm gonna go find this table towards the end of your textbook, but remember in the assignment and the exam they should give you these tables. And there we go, I've paused it. That's what I'm talking about. There's the standard normal table, the Z table. If you look at the diagram on the top, it's showing you that the area shaded from 0 to any Z value is what it will give you inside this table. You just need to tell it what the Z value is. So in our case, if you look at our example, our Z value is 1.78. So if you go to our table, the Z value going down the margin, we're going to look for 1.7, because the values on the margin going down only goes up to 1 decimal point. So there's 1.7, there we go, and the value on the horizontal border is the second decimal point. So there's 0.08. So we're looking for 1.78, so it's 1.7, and where it intersects 0.08 is 1.78. And if you look at that probability, that's the green area that I've shown you in the curve. It's 0.4625. That's this green area. This is the 0.4625. That's how I got it. Okay, by looking at the table. I'm just going to make sure that's it. 0.4625. That's correct. So remember what I told you. If I wanted the black area, I just need to take 0.5 and remove this area here. All right. So I'll say 0.5 minus 0.4625. 0.46. I should have typed this, but it's okay. You get the point. And if you subtract this value, you get a value of about 3.75%. Right? 3.7. I'll write it down. 3.75%. You'll notice if you look at the answer in your textbook, it's about 3.772 or something, 3.722. The reason why it's slightly different is because the textbook uses Excel to compute it. So for us, we had to round to 2 decimal points here, but with Excel you can take it up to many more decimal points. You can actually make it more accurate, but the answer is still right. Okay, it's a matter of accuracy. All right, so 3.75%, and remember, provide an interpretation, right? Provide a statement. So you would say, if you look at the question, it says what percentage of households is likely to use more than 300 liters? Then you would say the percentage of households that is likely to use more than 300 liters of water per day is 3.75%. Remember, percentage and probability, it's the same thing, all right, in this question. All right, so I hope that makes sense to you. I think my mouse died on me again. Just give me a second. We're back. Okay, I'll do the second question. And I thoroughly encourage you to work through this problem on your own to get to the same answer. All right. Getting there. All right, there. All right, so now I'm just going to keep my Z curve. With centered at 0. Okay, now we've done 1, and let's do 2. It says, what is the probability of finding a household that uses less than 100 liters of water per day? Now remember, X is the daily water usage. So we're asking, what is the probability of X being less than 100? That's what we need to solve. Okay, now remember, we need to convert this to a Z. So we say probability of Z less than. So we'll follow this formula again here. It's x minus mu over sigma, so our x is 100, so 100 minus the mean, which is mu, which is 220, divided by sigma, which is 45. And if you do that, you left the probability of Z being less than, I believe it's minus 2.67. 2.67. All right, now this is, if you look at it, we've done the curves, we've sketched the curves. Let's just sketch what area we're looking for. We're looking at where Z is less than minus 2.67. So there's our Z axis. Now it's minus 2.67, so it's a minus number, so it's on the left of 0. So say that's our minus 2.67, minus 2.67. Right? And we're saying Z less than that, so that means it's this area here on the left of it. This is the area we need to find, and we've solved our problem. So remember what I told you, that this curve is symmetric. So if you found the area on the left of minus 2.67, then equivalently the mirror image would be positive 2.67 on this side. So here it will be positive 2.67, and that is the same area that I'm interested in. And the reason why I'm going to the positive side is because the textbook or the tables you'll be given for your exam and your assignment It only deals with the positive numbers. Okay, mouse again. There we go. Should be back. There we go. Right. So what we do is, I want this area here, and then I've solved the problem. Remember what I told you? The textbook gives you this area instead. It gives you the area from 0 to any z value. So what do we do? As before, we say 0.5 minus this green area will give us this area. In other words, you can write it like this. You can write it as the answer being, we're going to take 0.5 and we're going to subtract this green area is the area between 0 and 2.67, which is, in other words, is the probability of z being between 0, right? Z being between 0 and 2.67. That's how you write it mathematically when you're talking about the area from 0 to 2.67. You write it like this. And this you can get from your table in the back of your book. That becomes 0.5 minus, and this area I believe is 0.4962. 0.4962. So do that as an exercise to confirm this. And if you subtract that, the final answer is 0.38%. So the final answer is 0.38%. I've already converted to a percent. All right, and then provide a statement. And I'll leave that to you to provide that. Most of the work is done here, and that's the last step. Okay, so that's the normal distribution, and I've covered the binomial distribution. I'm going to leave it to you to go over the Poisson distribution. And any questions, please feel free to let me know. And I hope this helps you. Okay, all the best and chat soon.